Everything in the universe is moving. Even now, sitting in your chair, you are moving because the Earth is spinning around its axis with 0.3 kilometers per second. At this same moment, the Earth is circling around the Sun with a speed of 30 kilometers per second. The Sun circles around the super black hole in the center of our Milky Way with more than 200 kilometers per second. Our Milky Way is a member of the so-called local group of galaxies, which is attracted with a velocity of about 370 kilometers per second in the direction of the Virgo galaxy cluster. But the Virgo cluster is just a small part of about 100,000 galaxies in the Laniakea supercluster. The Virgo cluster accelerates with about 600 kilometers per second to the mysterious Great Attractor. In other words, we are moving, you are moving with at least 600 kilometers per second to the Great Attractor. But in this theoretical model of a universe in free fall, we are moving faster, way faster than that, as you will see in this video presentation. For almost 100 years, thanks to the observation of the famous American astronomer Edwin Hubble, we now know that the light of most of the galaxies that surround us is red-shifted. Apparently, the galaxies are moving away from us. This led to the idea of an expanding universe. Based upon Einstein's General Relativity, the expanding universe was first proposed by George Lemaitre in the 1920s. The world-famous Albert Einstein thought the universe was static and did not believe at first in Lemaitre's theory of l'atome primitive, as Lemaitre later named it. Even in the theory of a quasi-steady state universe proposed by British astronomer Fred Hoyle, expansion and continuous production of matter was added in his theory. Since the 1960s, with the discovery of the leftover radiation called cosmic microwave background, the Big Bang theory was generally accepted and fine-tuned by many others, which led to the standard model of the Big Bang cosmology. But what if I told you the universe is not expanding, at least in this proposed universe in free fall? There is another overlooked explanation for the redshift in the light of actual receding galaxies, and that is gravity. Imagine what happens if all galaxies were in free fall. They are continuously accelerating away from each other. Why? Because they're all falling down, because obviously in the same direction. An example. Consider the three galaxies falling down as seen in the schematic drawing of the universe in freefall. The lower galaxy had more time to accelerate than the middle galaxy. Therefore, the falling speed of the lowest galaxy will always be higher than the middle galaxy and continues to increase with every second. Both galaxies will move away from each other and see each other in redshifted light. This is the doppler effect and not the expansion of space. The same reasoning applies to the middle and the higher galaxy, where the middle galaxy now is the lowest galaxy and falls away from the higher galaxy with increasing speed. Again, both galaxies see each other in redshifted light and move away from each other as well. In other words, if all galaxies are in free fall, they really move away from each other, and that is the reason why each galaxy finds itself surrounded by redshifted galaxies. And the further away a galaxy is, the faster it will move. The universe is not expanding. Of course, now you may ask, if they are falling down, where do they go? Well, all galaxies are falling down to the center of the universe, and the best candidate just had to be the Great Attractor. The Big Bang theory tells us that the universe started 13.8 billion years ago, from a single point of mass, a singularity. Thanks to the Hubble Space Telescope, we can observe small, young protogalaxies, even at 13 billion light-years distance. So, how could the universe have grown so big in just 800 million years? The universe could not have grown so big, because mass should have exceeded many times the speed of light. So I concluded the universe already was there, as big as it is now, right from the start. This is a schematic drawing of the universe in freefall. According to this model, we live in a huge black hole, a sphere, outlined by this circle, the event horizon. Our universe is filled with oscillating dark matter. There is a downstream and an upstream, so empty space is not empty. It is full of moving dark matter. Each dark matter particle is gravitationally attracted by all the other dark matter and will fall frictionless from event horizon through the center, the Great Attractor, and then shoots up again to the opposite event horizon, where it will fall back down again. The oscillation will go on endlessly. Furthermore, this model claims that during its fall towards the center of our universe, dark matter is continuously compressed and condenses or materializes at 0 degrees Kelvin into baryonic matter. This is subatomic normal matter. Condensation should release a form of energy. This just had to be the CMB, the cosmic microwave background radiation. The CMB radiation is a temperature measurement of about 2.7 degrees Kelvin, so very low temperature. It is produced all around us. We are submerged in it. So in this model, dark matter is a cosmological building material for normal matter. There is no horizon problem because the condensation process starts from 0 degrees Kelvin and is not the cooling down effect of higher temperatures. Baryonic matter is continuously produced throughout the entire universe. But things are abruptly reversed in the Great Attractor, the center of our universe. The center is best described as a three-dimensional particle accelerator, but at a cosmic scale, where even galaxies are considered as particles. All matter will collide in the center when reaching, by definition in this universe model, almost the speed of light, and will spaghettify into dark matter particles again. Spaghettification is here the equivalent for the Big Rip. So here is our first answer to the question, how fast are we moving sitting in your chair? Because this local part of our universe, the Milky Way included, has fallen a very long time, and being so close to the Great Attractor, we currently are falling with about 98% of the speed of light. In only about 250 million years, the Big Rip will be our fate. As a result, we will end up as pure dark matter in the upstream. Calculations show that after a fall of 22.9 billion years, the universe recycles normal matter into dark matter again. Of course, I'm aware that this model is hypothetical and it has many very controversial properties like a center and an edge and more properties to come. But in my continuous search how to solve my puzzle of the universe, I'm referring to another video, the calculations of this model gave very surprising and encouraging results. It even gave clues for what dark matter might be. And last but not least, most known cosmological observations do support this model of our universe, as we will see in the following slides. This universe in free fall model can be calculated with this schematic drawing. This universe represents a huge black hole with a center and an event horizon. The speed at any particle with a mass m, little m, falls, like a dark matter particle, or like a star, or even a galaxy, it can be calculated easily with basic Newton laws. The conservation law of energy tells us that the potential energy at the event horizon is fully converted into kinetic energy in the center. The maximum speed v in the center, and by definition, is the speed of light. The left-hand side of the equation is the kinetic energy. The middle and the right-hand side are the equations for the potential energy. In the first square box, we can see the final expression where Vr is a linear dependent of little r. To my own surprise, it looks exactly like the almost 100 years old Hubble-Lemaître law V is h times d, where v is the receding speed of galaxies and is also linear dependent of d, where d is the distance between us and the galaxies. H is the known Hubble-Lemaître constant and is equal by this expression under a square root. I have used here the value 67 km per second per megaparsec. The surprising finding was that this universe model gives an explanation for the Hubble-Lemaître constant. But here the h value is time independent and h decreases with the angle of observation relative to our own radius along we are falling. Knowing that the speed Vr reaches the speed of light in the center, we now can calculate the radius of the universe. This is capital R, with this expression outlined by the second box. Our universe is 14.6 giga light year or 14.6 billion light years. We can also fill in the speed of light c for Vr and capital Ru for little r in the original top expression. The simplified expression is outlined in the third box. It tells us that any mass m has an energy value of E is mc squared, similar to the famous Einstein equation. But here it is a combination of kinetic and potential energy. Although Einstein's Special Relativity is valid in this theoretical model of the universe, strangely enough, the speed of light has also a very controversial property, as we will see later in this video. From the expression in the third box, we can derive the expression for the radius of a black hole. Ru is g mu divided by c squared. This expression applies to any size of black hole in this model. Note that the Schwarzschild radius and the Newtonian radius of a black hole both have a factor 2 in the numerator. The difference is caused by the definition that the speed of light is reached in the center and not at the event horizon. The expression for the total mass of our universe in free fall is in box number 5. It consists out of 3 universal constants: the speed of light, big G, Newton's gravity constant, and the Hubble-Lemaître constant. The total mass of the universe is 1.86 10 to the power 53 kilograms. Note that this could be 100% dark matter with normal matter included, because, as a hypothesis, normal matter is made out of dark matter. The expression for the age of the universe is in box 6. The age of the universe stands for the time to fall from event horizon to the center, the Great Attractor. The time to fall to the center is 22.9 gigayears, or 20.9 billion years. Okay, that's more than enough calculations. Let's see if this universe model can explain more known phenomena in the sky and can do some specific predictions. If the universe has a center, then many puzzling known observations can be explained with this theory of a universe in free fall. This is why the CMB dipole divides the sky in two halves. CMB is a cosmic microwave background radiation in which we are submerged. The radiation is produced by compressed dark matter. It is not the cooling down effect of the Big Bang, but here it is a local phenomenon that every falling galaxy will observe. The radiation is in the frequencies of hundreds of gigahertz and corresponds with a very low temperature of 2.7 degrees Kelvin, just above the absolute zero. In other words, dark matter interacts with itself and condensates from 0 to 2.7 degrees Kelvin. The CMB temperature is slightly more compressed, thus slightly warmer in front of our falling Milky Way and slightly colder at the back. The temperature difference is only a measured 7 millikelvins. Another phenomenon, the so-called axis of evil, has also been found in the CMB and shows tiny temperature differences that can be explained by the movement of our solar system within our Milky Way. Our Milky Way and other galaxies in this model are rotating disks mainly made out of dark matter with stars and gas distributed throughout the galaxy disk. More about how a galaxy works and how its supermassive black hole in the middle may have formed later in a separate video. On a larger scale, in a 500 million light-year sphere around the Great Attractor, red and blue doppler shifted galaxy clusters nearby each other should be observable. The Laniakea galaxy supercluster indeed does show this phenomenon. Other observations also show in their reports red and blue shifted galaxies. Another good example for the center of the universe might well be the flow of galaxies towards the Shapley attractor and flows away from the dipole repeller. The so-called dark flow is yet another good example. Far behind the Great Attractor, from about 1 billion light years and more, half the sky should only show blue doppler shifted galaxies. Unfortunately, most of our view in that direction is partly blocked by the galaxy disk of our Milky Way, the so-called zone of avoidance. Before the Great Attractor, from our Milky Way point of view, most of the galaxies are red doppler shifted. Big cosmological structures lie more or less on circles in the sky. This is one of the best predictions of this model. All matter falls and evolves in isochronous and spherical shaped layers. As matter falls down in layers, it has about 10 billion years more to evolve than in the Big Bang model. Matter will be stretched vertically due to the increased speed and will be pulled together sideways due to gravity. The volume of every layer will continue to shrink as it falls down towards the center. In a way, this is how spaghettification works, but here it is on a scale of the universe. This stretching and pulling together is responsible for the many known observations of huge cosmological structures in the sky. That is why they appear to lie on circles in the sky. Just a few examples out of a long growing list of huge structures that devise the cosmological principle of a homogeneous universe. The Sloan Great Wall, 1.3 billion light years wide, at 1 billion light years distance. Many large quasar groups, up to 4 billion light years wide and up to 6 billion light years distance. The giant arc, 3.3 billion light years wide, at a huge 9.2 billion light years distance. And the latest and greatest, the Hercules Corona Borealis Great Wall, up to 10 billion light years wide and a staggering 9.2 billion light years distance. This last example probably stretches out over more than 45 degrees in the sky. They are in fact the perfect evidence for the existence of isochronous time layers. Extraordinary claims require extraordinary evidence, said Carl Sagan with his famous standard. This universe in free fall theory can easily be proven or disproven by the following very controversial prediction. The speed of light is not a constant. Every year as we are falling, the speed of light physically decreases ever so slightly with a factor 1 over r, where r is the radius of our universe, 14.6 billion light years. All clocks in each layer will also tick a little slower the next year with the same factor 1 over r. Both will result in a slowing down effect. I have calculated that the speed of light decreases with 4 centimeters per second per year. Einstein's theory of special relativity, however, is not violated, but it's limited to every isochronous layer because only there the speed of light is constant. Every layer is another different domain for Einstein's special relativity. General relativity is considered not applicable, because the universe is not expanding in this theoretical model. Newton's laws and special relativity will do the job. Einstein's spacetime can be replaced by the hypothetical timespace. Timespace is the name I have respectfully given to the whole set of isochronous spherical shaped layers made out of falling and upshooting dark matter with decreasing speed of light and slower running clocks. The Moon can play an important role in proving this very controversial prediction. Since the Apollo moon missions in the 1970s, the Lunar Laser Ranging Experiment measures for many years the distance between the Earth and the Moon with a powerful laser beam. The results suggest that the Moon on average spirals away from Earth with plus 3.8 centimeters each year. This is very strange, of course, since all objects in the universe with a mass attract each other. They do not repel. In fact, the Earth becomes heavier each year with about 50,000 tons of meteorites, and so does the Moon with several thousands of tons per year. The Newtonian attraction force between the Earth and the Moon will become a little bit stronger every year. If you are measuring the distance from Earth to the Moon with a beam of light, let's assume it's a fixed distance of 385,000 kilometers, then this system will produce every year a positive error, or a systematic error, of 5.2 centimeters per year. As mentioned before, this is caused by the decrease of the speed of light and slower running clocks. You might mistakenly conclude that the Moon spirals away from Earth with 5.2 centimeters each year. But the distance Earth to the Moon is not fixed. Decades of accurate measurements performed by the Lunar Laser Ranging Experiment, the Moon seems to spiral away from Earth with plus 3.8 centimeters each year. The universe in free fall model claims that the systematic error should be subtracted from the actual measurement. The correct answer then should be 3.8 minus 5.2 is a minus 1.4 centimeters. In other words, the Moon spirals inwards. It comes closer to Earth with 1.4 centimeters each year. But don't worry, that is 14 kilometers in a million years. So we are safe, for now that is. Unfortunately, physicians and physics labs do not measure the speed of light anymore. Why is that? Because international measuring authorities have declared since 1983, and according to Einstein's Special Relativity, that the speed of light is a true universal constant. And of course, who has the courage to prove Einstein wrong? Perhaps one day the speed of light may prove that the universe really is in freefall, where everything inside this huge universe-sized black hole is falling. Even now, sitting in your chair, you are moving, you are unstoppable falling with almost the speed of light. Within 250 million years, we all will meet our inevitable fate of a big rip. But cheer up, in spite of this doom scenario, 250 million years is plenty of time to enjoy life. Thank you very much for watching my video.